Hello everyone, welcome to the past paper discussion. So we are in new series and the first question of the series. This is the first question and it is quite bigger one, like it carries 29 marks around. So let's get into this. It is basically probability and testing based questions. Yeah, let's get started. Okay, and in this, it is an in-depth investigation based question. Okay, so there are two friends, Peter and Helen. They are discussing ways of predicting the outcomes of international football matches involving Argentina. So Peter suggests analyzing historical data to help make predictions. He lists the results of the most recent 240 matches in which Argentina played in chronological order, then considers blocks of 4 matches at a time. He counts how many times Argentina has won in each block. And we can see that table over here, right? Number of wins for Argentina per block of 4 matches, like 0 wins, 1, 2, 3, 4, all wins. And the frequencies is given, right? So this is a description. Now first question on this, determine the mean number of wins per block of 4 matches for Argentina, right? So mean number of wins per block of 4 matches for Argentina. It's quite simple. We can use GDC here for quick and accurate calculation. So let's go. And before that, what's the formula for like mean? This also I can use. It's nothing but sigma f times x by sigma f. The frequency times this, you will multiply and then you will add all this and divide, right? But yeah, now we can use GDC, right? Let's go. So first to find the mean here, you just create a spreadsheet with X as the number of wins and frequency as F and start listing your values. We have 0, 1, 2, 3, 4 as X and frequencies 0, 11, 21, again at 21 and a 7. Right, so these are the values. Now we can just go for stat calculation to calculate the mean. So statistics, stat calculation. We are dealing with one variable, right? The number of wins and frequency. So don't consider as two variables. So one variable, number of list, we have 1. And x1 list, like we already defined it, which is x. Frequency is defined as f. Category list include categories, that is not. So our first result column will be on starting with D and click OK. So here we have the result x bar, sigma x square, but we are looking for a mean. So the mean number of wins is 2.4. Can you see over here? So that's simple. We can calculate this quickly and we got it. So from the GDC, we got this. Mean number of wins equal 2.4. Right? That's simple. And moving to the next part. So in second case, that is a different situation. Peter thinks that this data can be modeled by binomial distribution with n is equal to 4 and decides to carry out a chi-square goodness of fit test. Okay, so he thinks that this can be modeled as binomial model, right? And here we go. So in binomial model, he took this distribution with n as 4, the number of trials, and he want to carry out the chi-square goodness of fit test, right? So now the question here is estimates the probability for this binomial model. Okay, I have a binomial model, usually x distributed as binomially n comma p. So we know n, what is p, is what we need to estimate. That's quite simple. So P is the mean number of wins that we did just now did it, divided by number of trials, right? So this is the estimated probability, correct? So 2.4 is mean number and you divide it by 4. So we will get the probability, which is very simple, 0.6. So that's the first part. We estimate the probability. Now the model is complete, right? X is distributed binomially as 4, 0.6. Now the model is complete. Now the next question. Use this binomial model to find the probability that Argentina win 0 matches in block of 4 matches. Okay, so everywhere we are considering a block of 4, correct? Now we are gonna find out the probability that Argentina wins 0 matches. So probability of X is equal to 0 for this binomial. 4, 0.6, we are looking for probability of X is equal to 0. Quite simple. We can go for GDC and just solve this technically. Here we go. Let me take a new page. Yeah, we can go for calculator and menu, either probability or statistics. And we are going for distribution. It is binomial and we will have two options, PDF and CDF. So we are solving for exactly 0 wins. It's not like an interval. So probability density function. I know N is 4. We calculated P, 0.6 is optional. We have to give. We are solving for 0 wins. And click OK. This is all we got. Binomial probability is 0.256 for the 0 wins. Right? And moving to the solution page. That's it. So you can just list it out in your own way. So probability of 0 wins by Argentina in a block of 4 is 0.0256. So just 2.5 or 6% around. Right? And moving to the next part. Now, in the second part, find the expected frequency for 0 wins. So we just now calculated the probability, expected frequency of 0 wins. This is available in our formula booklet. So it is E of X is N times P, expected frequency. Here we go. So N is 4 we are dealing with. So we can give 4 for that. Okay, here we go. Okay, so now the expected frequency of 0 wins. Expected frequency is number of, so N times P we have, and It's quite simple. Just now we have calculated the p-value, which is 0 wins probability 0.0256. And this is not for per 4 blocks or something, right? So n is here. We should not mention 4. It's going to be 60. Where I got the 60, the total frequency. Here we go. So, and the frequency, the total frequency should be there. And this total will be 60. That we need to use over there. So 60 times P. And when you solve this simple calculation, we will get it around 1.536. And you can just state 1.54. This is the expected frequency of 0 wins. Now, moving to the next part. As some expected frequency or less than 5, so now Peter combines row in his table to produce the following observed frequency. So you can see the change in the tables, right? So 0 and 1, he combined it because the frequencies are less than 5, right? And now the observed frequency and expected frequency are listed out. He again uses binomial model to find appropriate expected frequency. Correct to 1 decimal places, it's given. Now we need to solve few sequence of questions over here. Right. So first, Peter uses table to carry out chi-square goodness of fit test to test the hypothesis that data follows binomial distribution with n is equal to 4 at the 5% significance level. Right? Fine. So now, we need to write the null hypothesis under this condition, then number of degrees of freedom, p-value, and our conclusion on this test. Right. So they clearly state that the test is conducted to test the hypothesis that data follows a binomial distribution with n and with n is given at 5% significant level. So H naught is gonna be data follows binomial distribution. With n equal 4, p equal 0.6. Right? So this is what we got. And now the hypothesis is done. Now carrying the test, number of degrees of freedom. So number of degrees of freedom depend upon the categories we have and the number of estimated parameters. So we are using binomial, right? The estimated parameter is just my p-value. So let me write the formula. Number of degrees of freedom equal number of categories minus 1 minus number of parameters, estimated parameters. Right? So number of categories is going to be, these are my categories, 0 or 1, together 1, 2, 3, 4. Totally 4 categories minus 1 default minus number of estimated parameters. We are following binomial. N is 4, P is the estimated parameter, so only single parameter. So 4 minus 2, which is going to be 2. That's the number of degrees of freedom. Yes, of course, we need this to carry out the chi-square goodness of fit test, right? So we found that we made the hypothesis, we find the number of degrees of freedom, we know n, we know the significance level. Now, p-value is another important thing. Right? So to calculate the p-value, we can just go with this. So using GDC, we can solve. You have observed frequency, expected frequency, and few values we have, right? So let's go. Let's use technology to solve. Right, go for menu and start test. We are going to perform chi-square goodness of fit, GOF we need to pick. And observed list. Oh, yeah, we need to create the list. Let's quickly do that. So Go to the spreadsheet. Observed frequency and wait. Observed frequency, I'm naming it as O, and expected frequency, that list I'm naming it as E. And let's just follow. So observed frequency is 11, 21, again 21 and 7 in this particular case. Unexpected frequency 10.8, 20.7, 20.7 again, 7.8. So we have this. After listing, we can just go for menu and stat test, chi-square GOF. Observed list, okay, we have defined as O. Expected list, we defined it as E. Degrees of freedom, we have calculated just now, right? In the previous problem, which is 2. And the result will have, so draw shade p-value. So if you want a graph, you can just click on it. That's it. Click. We got it. So chi-square p-value is listed. Chi-square statistic value is listed, but we are focusing on this, right? 0.954. We are focusing on p-value. That's quite simple. Let's switch. So I got p-value from the GDC as 0. Okay, they listed that way. 0.09, 0.9539. So you can approximate as 0.954. This is my p-value, right? And the next part. Conclusion. So we got p-value and we are testing at significance of 5% significance level. So p-value is 0.954 or 3, yeah, 4. And 5% is 0.05. And clearly my p-value is greater than. So here we can accept, we can write H0 is accepted whenever p is greater than this significance level. So we will accept it, right? So otherwise you can say don't reject. We fail to reject the hypothesis. So I am just writing in a simpler manner, accept H0, right? So, or you can say there is no evidence to reject the hypothesis. That's simple. Or don't reject the H0, anything else can be done here. Moving to the next part. Using Peter's binomial model, find the probability that Argentina will win at least one of their next 4 international football matches. Okay, so we know his model, that is X is distributed binomially with 4 trials and 0.6. And we want a probability at least one of their next matches. He will win. At least means 1 or 2 or 3, more than 1. 1 or more than. So X greater than or equal to 1. And this also we can solve using GDC. Now, moving to the GDC part. Take a new page. Add a calculator. We are going to solve binomial distribution. And here it's a CDF, not because we are looking for an interval greater than or equal 1. So number of trials is 4. Probability of success is 0.6. Lower bound is 1. And upper bound is still infinity. You give a very big number, just put a lot of 9. And I got 0.9744. That's simple. We got the probability. And let's switch to the solution page. So I got for this as 0.9744. That's pretty easy. And moving to the next part. Next, there is quite a big description over here. Helen thinks that the better prediction might be made by considering the transition between matches. To keep the model simple, she decides to use only 2 states, Argentina won or Argentina did not win. So Argentina won is A, Argentina didn't win is B, right? Helen looks at Peter's list of results and counts the number of times that Argentina won. Twice in succession, Argentina won, then did not win. Argentina did not win, then win. Argentina did not win, then also, like in twice successive, right? So this list is given to us. And Helen uses the relative frequencies to estimate the probabilities in a transition matrix. Now, first part, we need to prove, given that Argentina won the previous match, we have to prove that estimate probability for that Argentina will win the next match also is 17/29, right? So it's quite simple. So first, what is the probability that Argentina wins given that it wins the previous match? Okay, probability that Argentina wins given that it wins the, so A means wins, Argentina won, B means Argentina did not win. So this is the probability. So it's quite simple. Frequency of Argentina wins in both the matches. They win in the previous also here. That is what I am looking for. So what are the possible outcomes? They win in the first match. So this is the win in the first match and the second. In both the things, Argentina won first and rest is like different. So it's frequency of AA plus frequency of AB. So it's 85/85 plus 60 and very simple plus simplification. 85/145. When you simplify, you will get 17/29. Yes, we have proved it. This is a proving based question. We need to prove this one and we did it. That's simple. Now, F second part, write down the transition matrix for Helen's model. Okay. So transition matrix is going to be like A, B. Here AB. I took in this way. So I know AA is going to be this AA, this AB, this is BA, this is BB. We found one, but we can find the rest also in a similar way. The first one is just an example for it, that probability of AA is 17/29. A given that A win the match. So BA will be 1 minus 17/29. So how to find this particular probability of AB? So probability of AB is nothing but I want Argentina to win given that Argentina did not win in any of the matches. So did not win means like 32 and 60. 62 and 32 in the first match, right? So here I will pick Argentina did not win in that. Okay, so 62 and 32. Here Argentina did not win. And so this is gonna be 62 plus 32. In that I want Argentina won the match. So there it is A1. That is the BA part. The frequency is 62. So 62/62 plus 32, when you simplify, you will get 31/47. 62/94, and when you simplify, it's 31/47, and this will be 1 minus 31/47. Right? And let's simplify. The transition matrix is 17/29, 12/29, 31/47, 16/47. This completes the transition matrix. Now, that's simple. Now the another part. Show that the characteristic polynomial of T is this. Okay, how to find characteristic polynomial? It's very simple. This is the formula. Determinant of T minus lambda I, whatever your matrix is working. We are working with T, so I put this is the equation, right? So I know my T, so I need to put like this. And what is my T? 17/29, 12/29, 31/47, 16/47, minus, I don't know what is lambda. So lambda I is going to be, lambda I is, we are using my transition matrix is 2 cross 2, so respective. So I will get lambda 0, 0 lambda equals 0. Right? Now, let me simplify this. It's a normal subtraction. So each corresponding 17 by 29 minus the corresponding element for 17 by 29 is lambda. Then 13 by 47 minus the corresponding element is 0. So we are not doing that. So 12 by 29, the corresponding element is this. So 12 by 29, since it's 0, it doesn't affect. 16 by 47 minus lambda equals 0. So now we need to just find the determinant. And determinant means this minus this. So cross multiply, like if you have A, B, C, D, determinant is nothing but AD minus BC. So in that way, 17 by 29 minus lambda times 16 by 47 minus lambda. Then the formula have a minus when you switch for the terms. Minus 12 by 29 times 31 by 47 equals 0. Right? And then it's quite a normal multiplication, but it's time consuming. Let's do that. Let me multiply these. 17 times 16 by 29 times 47. Then minus 17 times 16 by 29 times 8. 17 by 29 lambda. Then minus lambda, you want to multiply it over here. Minus 16 by 47 lambda. Then lambda into lambda, it's lambda square, and this will stay like minus 12 times 31 by 29 times 47 equals 0. Right, so we can do one thing. Everywhere, let me make the denominator same by multiplying 47. And yeah, you can even do in your own way. So here, I need 29, also 47. So now, overall denominator, I will have 29 times 47. I make them common, equal 0. So 17 times 16. 17 times 16, it's going to be 17 times 16 minus 17 times 47 lambda minus 16 times 19 lambda plus 29 times 47 lambda square minus 12 times 31. Okay. And this is normal simplification. If you do that, you will get 1363 lambda square. This will go. I'm writing in a polynomial format. Then this and this you will combine and you will get minus 1263 lambda. Then this constants when you combine, it's minus 100 equals 0. So it's also proof, like we need to prove this. So just compare your answer. And yeah, we can do some additions if we feel something is wrong. So that's simple. And next, we have to hence or otherwise find eigenvalue for t. When you have the characteristic polynomial, eigenvalues just simplify and you just stateless. Like solve that one. So just graph this polynomial and find the 0. Again, we're going to take the help of technology here to find the eigenvalues. Here we go. And we're going to graph it. Right. And this is 1363 lambda square, but I'm treat this x square times x square. Then minus minus 1263 lambda status x here plus minus 100. So I got this, correct? Now I need to find the 0. So go for menu and you can even zoom to the first quadrant. And let me change the window settings. So we can see this and it's somewhere over here. That's fine. So go for menu, analyze graph 0 and it's cross the x-axis over here. We just go around. It's 1, 0. Okay, so let's check for the other. This is 1, 0 and one more 0 is over here. Again, go analyze graph 0 and check here. So we got both the zeros listed, right? And that's simple. Now we can interpret our result. Moving forward. So the eigenvalues are from the GDC, I got these. Right? I just graph the characteristic polynomial, find the zeros. So lambda is equal to 1 is one eigenvalue and negative 0.0734. Let me take with 3 significant figures. That's simple. And next part. Find the corresponding eigenvectors. Right? So eigenvectors is quite simple. This is the formula. Lambda I minus A times the x vector equals 0. We know lambda. So for when lambda equal 1, what is the respective eigenvectors? There are infinitely many. You can just list one or you can just list it many also. So I'm going to list one. So lambda I. My lambda is 1. 1 into the identity is just this. Correct? 1001. Minus, okay, here we are using t. So we can change the formula like this. T. Minus t is this. 17 by 29, 12 by 29, 31 by 47, and 16 over 47. So this entire thing multiplied with xy, and a vector. So you can just name it as AB or whatever you want, equal 0. Now we need to simplify and then we need to make a vector. First is quite simple. Subtracted 1 minus 17 over 29. So what is 1 minus 17 over 29? And 0 minus 31 by 47. So just minus 31 by 47. 0 minus 12 by 29. So minus 12 over 29. And here 1 minus 16 over 47. Here A, B, I took equals 0. Now, just simplify this. 1 minus 17 by 29. It's minus 12 by 29. Here also minus 12. Wait. Plus 12 by 29. Then minus 12 by 29. And this is minus 31 by 47. This is plus 31 by 47. Into AB equals 0. And you just take one row multiplication like usually will multiply, right? I want to express A in terms of B or B in terms of A. So 12A by 29 minus 31B by 47 equals 0. Right? So let me express in terms of B. Minus 31B by 47 equal minus 12A by 29. Minus minus cancelled and my B is 12 by 29. This 3147 will get reciprocated when we switch A. And when you simplify it further, B is 12 times 47 is 564. And this is going to be 899. A. Okay. After expressing in this way, the eigenvector is 1. You treat A as 1, then B will become 564 by 89. So this is enough. But we know infinitely many vectors is there. We can give a t and t not equal 0, you can put. Right? Now, Okay, for lambda equal to 1 we did. For lambda equal to that negative 0 point, that eigenvector also I need to find. When lambda equal to negative 0.0734, what is the eigenvector? Same process we should repeat, lambda I minus a, but quite here it's difficult. Okay, lambda's I is going to be negative 0.073400, negative 0.0734 minus, okay, here what is our A? Transition matrix T. 17 by 29, 12 over 29, 31 by 47, 16 over 47. And this times, which is AB equals 0. And simplify this further. The same way we need to do. So directly I'm giving you this negative 0.0734 minus 17 by 29. Correct? Corresponding elements will subtract. And then 0 minus this. So that's just minus 31 by 47. And 0 minus this. Just minus 12 by 29. Minus 0.0734 minus 16 by 47 into AB equals 0. And simplifying this using calculator, negative 0.659607, negative 31 by 47, negative 12 by 29, negative 0.732974, AB equals 0. And when you take the first, as usual, like take the first product, negative 0.66a minus, so I just approximate this, then minus 31 by 47b equals 0. Again, I'm going to express b in terms of a. Minus 31 by 47b equal 0.66a. And b is 0.66 times 47 by negative 31a. And when I solve this, I will get it around minus 3102 by 3100 a. And which can be simplified as minus 1.00064a. This I can just take it as approximately, you can just consider as 1, right? Right, that's it. And we got my A is 1 means what happened to my B? It's minus 1. This is the second eigenvector. When lambda is negative 0.07. So when we deal with fraction, we will get it exact. But yeah, we can make in this way also. Right? So corresponding eigenvectors is done. Correct? Now moving to the next part. In her retirement, many years from now, Helen is planning to travel to 3 consecutive international football matches involving Argentina. Use Helen's model to find that probability that Argentina will win all the 3 matches. Okay, probability of all wins, all 3 wins. Okay, so probability of all 3 wins means, so using transition. So first match, they should win. That is probability of winning the first match times, they are independent, right? Probability of winning the second match, so that they should win the first match also. Probability of A. So they win this first, probability of winning second, given that they win the first match also, they should win. Times probability of, most of us will do like this, probability of triple A. No, not like that. So here we should do again probability of AA. What this means is probability of winning the third match, given that they win the second match. Correct? So this is an important Markov property. So the future state depends only on the current state. Right? So not on the initial state. Right? That's why we are not considering. So P of A, then second one is Argentina wins, given that they wins the first match. In the third match, Argentina won the third match, given that Argentina win the second. This is the way we need to do. So probability of A can be found by, we have the transition matrix, right? So raise it to the higher power. So probability of A is, we have 17 by 29, 12 over 29, right? And then 31 by 47, 16 over 47. You raise it to any other, because it's many years from now. You just, that is what given. Many years from now, we are going to discuss the probability. So just use 150, whatever you want. And that will be P of A. And P of A, we will just see that now. This is P of A, correct? This is A and A. And it is going to be 17 by 29. Again, 17 by 29. So P of A, we need to find it by using this, correct? And we are moving into GDC now. Quite simple. Take a calculator. Right, define a matrix first, or just we can 2 cross 2 matrix, whole power. Let me use 100. And let's give the input. The transition matrix, 17 by 29, 12 by 29, 31 by 47, and 16 over 47. So 16 over here, 47. That's it. Okay, we got in fractions. But anyways, let's try to make into decimals. Go for action. Convert to decimal. So we got this. Even if you raise it to 100 powers, this is going to be the probability. The basic, like if you increase the number of trials, the probability is going to be the same, right? And this is actually A probability we are looking at, 0.61449. This is what we are going to take, not B, correct? And we can just use it for P of A. 0.61449. So I'm just using 4. And you just simplify all this, you will get it around 0.211 to 3 significant figures. And so we can conclude there is 21.1% probability that Argentina will continuously win 3 matches, right? And this completes the entire solution. Hope you might found the video helpful. So let's meet in the next question of this series. Until then, keep learning. Thank you for listening.